Okay, for example, 3f of x equals secant of x over 1 plus tangent of x. This is the easiest kind of one to do. It's a quotient, obviously a quotient, right? One thing you can establish with trigonometric functions, back in chapter 3.3 we did a bunch of algebraic manipulation to make the problem simpler, right? Okay, with trigonometry, back in trigonometry chapter 6 of the trigonometry book, our favorite chapter, everybody always lies the next class about, we hate chapter 6, that one.
I like
the trigonometry. Some of us actually do like trig identities. That's fine. I like trig identities. Anyway, the purpose of that chapter is to give you some ammunition for a problem like this, because this is not terribly difficult to do, honestly. I mean, we could do it. It wouldn't be very hard. But look at this. Secant of x over 1 plus tangent of x. If we recall our trig identities, secant of x is 1 over cosine of x. And tangent of x is sine of x over cosine of x. Okay, that's accurate right there. And you might be thinking to yourself, why do we go from this nice, concise looking little thing into this uglier thing here? But notice, once we create this complex fraction, look, now if we use a little algebra, multiply the top and bottom by cosine of x. We got to multiply the entire bottom, so we distribute. We get f of x equals 1 over cosine of x plus sine of x. And it's got the same number of trig functions in it, right? Got a binomial denominator now. But what I want you to see about this, though, is derivative of cosine is negative sine, derivative of sine is positive cosine. Those are the easiest two trig functions there are. Secant tangent, secant squared, those are a little bit more challenging. Also, 1's the top. What's the derivative of 1?
0.
0. So that's going to make one of the terms disappear. Okay, that makes it easier. So this has a derivative, that has a derivative, there's no zeros in that one. So this is an easier derivative to do. So I would probably go with this one if I were doing the problem. So it's still a quotient, so I still have to use the quotient rule. And if you remember the quotient rule is low d high minus high d low over the square of what's below. That's the rule. Low being bottom, high being top. D high meaning derivative of top, D low meaning derivative of bottom. Alright, so the top is 1. The bottom is cosine of x plus sine of x. And we just apply the rule and put things where they belong correctly. So when I do f prime of x, I'm applying the quotient rule, so I'm doing calculus. Once I do calculus, I put a prime on my f prime of x. And I create this big fraction bar. Low, cosine of x plus sine of x. D high, 0. Minus, because the rule tells me to do minus, and then high, 1, d low. Now look at low. We're doing, again, looking at structure. It's a cosine function being added to a sine function. So it's a sum of functions. Sum and difference of functions is derivative of each individual object. So I simply have to differentiate this, plus, and then I differentiate that. It's a sum or difference, you differentiate each piece. It's not a product, it's not a quotient. It's a polynomial type structure with trig pieces in it. So each individual trig piece can be differentiated based on its derivative. Derivative of cosine is negative sine of x. Derivative of sine is positive cosine of x. Over the square of what's below, that's just cosine of x plus sine of x, the quantity squared. Take the bottom as it is squared. Right? And again, what that did for me, that's 0. So that's gone out of the picture, not doing anything. Then I got a negative 1 that's being distributed through here. So I end up with f prime x is going to be sine of x minus cosine of x over cosine of x plus sine of x. Quantity squared. Real quick, just again for the idea of why would we want to do this? Suppose this was upside down. 1 plus tangent over secant. It's still the same difficulty problem for that, right? If you changed it to this, you would have gotten cosine of x plus sine of x. The derivative would have been negative sine plus cosine. Done. Okay, so again, modification using trig identities is helpful. So make sure that you have that ready and available to you.